Now that we know how to find determinants, let's talk about Cramer's rule. Cramer's rule is actually a really nice, very quick way of solving systems of equations. Now, here's how the rule works. We're going to start by writing our system of equations like we did last lesson, using our three different matrices, our coefficient matrix, our variable matrix, and our constant matrix. From there, we're going to find the determinants of various matrices, put them into fractions, solve them, and that's our answer. So let's look first at a 2 by 2. Let's take this 2 by 2 here. They used a lot of letters, but we can still write it as our three different matrices. Our coefficient matrix is this. Our variable matrix is x and y, and our constant matrix is this. Now, to solve for x, what we're going to do is make a fraction. In the numerator of the fraction, I'm going to make a very special determinant where I replace the x column with the constant matrix. And then I leave the other column the same. So this is like my x column and my y column. So I take my coefficient matrix, I switch out the x column because I'm solving for x, leave the y column alone, divided by the matrix of the coefficient matrix. Or sorry, not the matrix, the determinant of the coefficient matrix. And that solves for x. Then to solve for y, we want to take the coefficient matrix, but now I'm replacing the y column with my constant matrix and leaving the x column alone. And I divide by the determinant of the regular matrix. And that will actually solve for x and y of your system. And it even works with bigger systems, a 3 by 3. We have our constant matrix, we have our variable matrix, I always mess that up, coefficient matrix, variable matrix, and our constant matrix. So to solve for x, we replace the x column with the constant matrix, leave the rest of it alone. For y, we replace the y column with the constant matrix. And finally, for z, we replace the z column with the constant matrix. And then we solve those determinants, divide by the determinant of the regular coefficient matrix, and that's how you solve your system. It's actually pretty quick once you get those determinants done. So let's try an example here in example 4. Here we have a 2 by 2. We're going to start by writing it as our three matrices. Our constant, our oh my goodness, I did it again. Our coefficient, our variable, and our constant. So coefficient matrix, 2, -3, 5, 1. Variables are x and y. And our constants are 4 and -2. So if I want to solve for x, I'm going to do the special x determinant where I take the coefficient matrix right here, my coefficient matrix, except because I'm solving for x, I'm going to replace the x column with the constant matrix. So I'm going to take here, let's color code them. There's our constant matrix, actually. Let's do our constant matrix pink. Whoa, too big. There we go. I'm going to do our constant matrix pink, our x column green, and our y column blue. X, y, and our constant. So to find the determinant of x, I replace the x column with the constant column, and the y column stays alone. And then I'm going to divide by the determinant of the regular coefficient matrix. So to calculate y, we do our special y determinant. So now I'm going to replace the y column with my constant matrix. Leave the x column alone. Divide by the regular determinant of the coefficient matrix. So, all we need to do is calculate these different determinants, and that is actually solving our system of equations, getting our x and our y that solve both equations. Thankfully, these are just 2 by 2 determinants, which means they're not too bad, AD minus BC. So we have our first diagonal, 4 times 1 is 4, minus our second diagonal, negative 2 times negative 3 is a positive 6. And same here, AD is 2, minus BC is negative 15. So 4 minus 6 is negative 2 over 2 minus negative 15 is 17. And that actually is our x solution right there. Now let's do the same thing for y. AD is negative 4 minus BC, 5 times 4 is 20. Divided by, this is going to be the same denominator as up here, so it's going to be 17. Same denominator because it's the same determinant. Oops. Oh wait. There we go. So this is negative 24 seventeenths. And that is our y solution. So right away, we have a solution to this equation at negative 2 seventeenths, negative 24 seventeenths. And so using our vocabulary, this would be a consistent independent system because it has a single solution. And if you had solved this system using any of our other methods that we've learned this whole chapter, you would get the same answer. So now that we've practiced with a 2 by 2, in the next video, we'll start looking at a couple more 3 by 3s. And that will be our last video for using Kramer's rule and determinants for lesson 6.6.